the ID is zoom out, which you see here. That is, what I get is a handle of an object that represents this element in my text, in my HTML document. So, and now this element has an attribute, in this case, or it has an attribute called onClick, and if I have a handle on it in JavaScript, then it also has a property called onClick, so just the same. And to this property, I can assign a function. So, you've seen how we defined this load map function, and now I assign to this object another function. However, this function is not static as this load map function. So first of all, it doesn't have a name, and second, it is actually created while I evaluate this statement here. So I have here a function definition that says map zoom to, well, exactly the same, but what we used to see written here in this JavaScript URL. So it basically does exactly the same. Now, however, this is assigned to the onClick attribute or property of this object. So and what happens is, or it turns out that what happens is, there's a function defined, and this function is an object. So and I can assign this object as a value to properties of other objects. And this is what I'm doing here. So and this event handling magic that is going on in an HTML page defines that if an event occurs, such like a click event on an element, and it has a property that is called onClick, and this property has a value of a type function, then this function is just invoked or called. So, and this is what I'm using here. So I assign this function to this onClick event, and whenever later this onClick event occurs, then this function is called. So now look what happens here actually. So this is evaluated or executed when the document is loaded. So when this load map function is executed. So, and I create this function there, and I assign it to this onClick property, and then I leave the function. So I somehow arrive here, and then my page is initialized, and this load map function returns, and everything is done. So, and this object has a new event handler, which is this function object, and nothing happens until I click on one of these links. So now look what this function actually does. So this function says map.zoom2 and so on. So and here it references map again. So now look what map now is. Map is defined up there as a local variable in this function. So, and other than previously where it was a global variable, it is now a local variable, and local variables go out of scope, that is, they vanish when the function terminates in which they are defined. So technically, after this function terminates, this map object that I defined up there is no longer around. So, because it's a local variable. Yet, inside this function that I defined here, but which is not yet executed, I access this map object. So, and this is, if you think through it, actually very surprising that this works. But of course it does. So it does work, and this property is not obvious actually. So therefore it has a name. So that's closure. So, and this function is called a closure, and it retains references to local variables in the scope where it was defined. Which is actually a very elegant thing to do. So, questions? Was this understandable at all, actually? Okay. Yeah. Yes. The question was, what happens? Happens with the created objects after this load map function terminates? And I'm getting to that actually in a minute. So just be patient.
May I ask another small question?
Where?
Here, right in the front row. The onClick event handler, does it also fire when you activate the link with the keyboard?
I don't know. You have to try it, actually.
Okay, and is it possible to write your code in a way so it degrades gracefully if JavaScript is disabled so that the links don't take you away from the page?
The question was how, if you can write HTML code such that it degrades gracefully. And yes, in principle you can, but in general, if you do more nifty things than just very trivial ones, it is not a good idea. I mean, it's just like writing applications for computers that don't have a CPU or don't have a processor or don't have memory or something. And it doesn't really make sense.
And
so
maybe
you still have to write books instead. So it's like websites and books.
And maybe a small remark, someone earlier asked about XHTML. Try your JavaScript inspector in the Firefox. Maybe it can reveal something, and it's true if you have XML documents, for example, the whole HTML DOM doesn't work anymore and you're lacking a lot of functions, and so you have strange and surprising results and wonder why your JavaScript scripts don't work anymore. So yeah, you really need to pay attention to document types and content types that are sent over HTTP. It's really important.
I didn't understand that at all. Okay. But okay. So what I try to demonstrate is how functions can act as values in this previous examples. That is, I create a function and I use this function not to execute it, but I use it to assign it as a value to a property of an object. And this object is going to do something about it later, such as calling it, for instance. So, and since functions turn out to be values and are objects and can be values of properties, they can, of course, also be returned from other functions. So, and to show you this, I've prepared yet another example, which looks very similar to the previous one, except that I now have this function makeZoom. So, and now again, I'm assigning something to these on-click properties of these link elements, but this time I'm not assigning a function that I create here directly, but instead I assign the return value of another function that I call. So this again is the name of a function, and if I write parentheses after the name of a function, I call this function. So this function is defined here, and it takes as arguments a map object and a number that I call delta. And this number is either 1 or -1, and which is the difference by which I change the current zoom level. So, and what this function does is actually quite funny. It returns a function. And this function does exactly what these other functions that I defined directly over there in the previous example. The difference now, and that's actually quite interesting, is that in the previous case, there was something that is called a reference loop, which means this object has a property that points to something else, which was in the previous case a function, and this function was a closure. And the closure creates references. I explained that a closure retains references to all local variables in the scope in which it was defined. So in all variables independently of which they are accessed inside the function or not. So that is, if I define this function right here, then this function is defined in a scope in which Zi is a local variable. That is, this function would have a reference to this variable Zi, and this variable Zi has a value that has a property that again has a reference to something that has a reference to itself. So that creates a circular reference, which is actually, in general, okay, because that's just very comfortable of the execution environment to take care of that and to still remove objects if they are no longer accessible, even if they have reference loops. However, if these objects that are part of the reference loops contain non-JavaScript objects, that is, objects that are provided by the runtime environment of Java, such as the browser, then this creates difficulties. So for instance, reference loops that contain DOM nodes in Internet Explorer create memory leaks because they are never removed. Even if you unload the page, those objects that are referenced are never removed. So while as in this case, I create a function in a scope where there are only two objects defined, or two variables are defined. One is map, and the other is delta. And there is no reference to this DOM node, ZI or ZO or something. Therefore, this function doesn't retain any reference to this variable, and therefore the assignment of the return value of this function to a property of this variable doesn't create a reference loop, which is very important, as I explained. And besides, this idiom or something is called factory functions. That is, you have a function that returns another function. It creates a factory. It creates a function. It's called a factory, and that makes it very clear which variables are actually accessed inside this dynamically created function, which is much better than create them just arbitrarily in a wider scope. So that's a good idiom and very hygienic to do anyway. Okay. Mm-hmm.
Why do you return false at the end of the function?
Okay. This function returns false. The reason for that is that this function is going to be called as an event handler. So now another concept besides events are so-called default actions. So some events in the browser or in HTML have default actions. For instance, clicking on a link usually loads the page that is identified by the URL contained in the href attribute of the link element. So it just loads another page if you click a link. And that's the default action of this click event. And if an event handler is defined for this event, and if that event handler returns false, then the default action is, as it is called, cancelled. That is, in this case, I prevent the click onto the link from loading another page, because that's not at all what I wanted to do. So, and that's why I return false from these event handlers. And besides, what I'm demonstrating here is only one way out of a few others to install event handlers. So that's the simplest possible, and there are other interfaces defined to install events. And I'm not going to talk about that now, unfortunately, because the time is too short anyway to do that. And as I said, I just want to give you an atmospheric impression of JavaScript programming. So, and I can't do much more than this. Okay, objects. I mentioned already that everything is an object in JavaScript, right? And there are several different sources from which object can come into the program. So, I mentioned already, though I'm not going to show you much more of that there is a rich vocabulary of literal expressions. So, for instance, one way of creating objects is just to enumerate all their fields or properties. So there, this variable point is an object that has two properties, x and y, of which both have the value 1. Another way to create objects is by using the new operator. So I can say new point, x, y, whereby point is actually a class that I defined myself. Or I can create built-in objects using the new operator, which is new date, for instance, creates a date object that represents a time, and if I call it without arguments, then I just get the time of now. So that's why I call this variable now. And there are objects that are provided by the host environment. That is, they are not coming from JavaScript itself, but they're coming from outside. So from the browser, in this case, or the document. So we have seen already this get element by ID, which gets us access to an existing element in the HTML page. Or we have such things like create element, which creates a new element, which I can then insert into the HTML page. Okay, and we've seen already that normally, or I mentioned already that normally objects are removed automatically by the runtime environment if they are no longer accessible from the code, so which is called garbage collection. So and there's no finalization as in Java or a destructor call as in C++. And I explained already that this doesn't always work in all cases. Okay, so we have seen already some instances how objects work. Basically, objects are container of properties. So objects have properties, and properties have values. and you can just assign any value to any property of any object. So there's no predefined set of properties that any object can have.